Thank you. So yeah, I've been working on a game this whole past year, almost a year and a half, and I've learned a lot about design and specifically how to cull down a decision tree. So I wanted to do a talk on that. So the value of constraint. So first of all, who is this guy? So I am traditionally a PC game developer. I've done a lot of programming. My first commercial game I'm willing to admit to was called Zero Gear, released in 2010, a go-kart game, racing, wacky power-ups, sports modes, and love robots. So this didn't have a lot of decision space, but it was more of a Twitch game. That's where I started. I went into Natural Selection 2. That was released in late 2012. This was a first-person shooter mixed with a real-time strategy game. So this was Aliens vs. Marines, a sequel to Natural Selection, a Half-Life mod. This was on our custom engine, and I was a lead programmer on this. So didn't do a lot of design, but definitely contributed some stuff here and there. This had a lot of interesting design decisions that we had to make as a team. And from there, I've been doing a lot of random, just sort of prototypes in the board game space since that time. And lately, I've been working on this game called One Last Job, which is an asymmetric two-player heist card game. So this has a huge amount of decision space, and we've had versions of this where, Adam and I are playing it for like an hour, and at the end of that, we just can't play the game anymore. Our brains were fried because we were having to evaluate way too many possibilities. So a lot of our design time over the past year has been trimming down the amount of decisions you have to make in this game to an appropriate amount. Let's talk about what is the decision tree, because maybe not everyone's familiar with this terminology. So it's a series of decisions a player makes which lead to an outcome, which sounds pretty straightforward. So you have a decision that leads to a few more decisions, and each of those decisions lead to more decisions, which eventually lead to a bunch of results. And so from decision point A, you have to if you want to play the game optimally, you have to figure out all these paths to whatever result you want to get to. And you have to think of those relative to, or in terms of all the decisions your opponent or your opponents are making in the game and find the correct solution. So it's a decision tree because it looks like a tree. So there's this question of, if I'm designing a game, there is an appropriate amount of decisions I want the player to have to consider on their turn. It's not simply I want them to have a lot of decisions or I want them to have no decisions. It's likely somewhere in between. So that's kind of what this talk is about, is finding the right amount. So let's go through a few examples. I like to use examples because I get to talk about games and I like talking about games, so let's use examples. So let's talk about hand size. So I had to very quickly come up with an image, and this is what I came up with. I apologize. So very quickly, take about 3 seconds. Tell me what is the best poker hand here. 3, 2, 1. Who's got the answer? It could be. I don't know. So my point here is, looking at this, I cannot tell you what the best poker hand is. This is ridiculous. This is way too many cards. Versus this is a lot more manageable. But I don't really have decisions to make here. Poker's not the best example here because you're not really making decisions as much as you're finding the right solution. But I want to use this as a demonstration of kind of how overwhelming a huge amount of cards can be for a player. So let's talk about this in the context of Magic. In Magic, you have a limited hand size of 7 cards. So this very much constrains the total number of options you have on your turn and on future turns too. If you maybe can draw 3 cards right now through some effect, but you're gonna have to discard 2 of those, and that affects the value of drawing those cards. So it helps players plan their turn, because in a hand of 7 cards, if I know the game, I could probably find 2 decent plays there. And then it's about evaluating those 2 plays based on the board state. And it also does some other interesting things, like I said before, limit the power of card draw based on that hand size. And going into card draw, there's a lot of decisions that player has to make here as well. So using Magic again, you draw 1 card at the start of your turn, and ignoring some pretty rare effects, that's pretty much it. You get the 1 card. So there's an information horizon here that's pretty limited. So when I'm planning my turn, I know that next turn I'm just going to get 1 more card. That puts a lot of constraints on what I can do this turn and what I can do next turn. So there's some downsides to this limited draw in Magic, which a lot of Magic players will definitely complain about, tell you about if you're getting into Magic. So you don't have as much control over your turn. If you're drawing a lot of your mana cards, a lot of your land cards in Magic, that's called mana flood. You have too much mana, you have too much land, you don't have the tools to execute on those resources. And the opposite is called mana screw, where you don't have enough mana. You don't have enough resources to play the cards that you have way too many of. So you don't have a lot of control over this. There are cards in Magic which compensate for this, but in the basic game of Magic, this is kind of luck of the draw. So there's some upsides and downsides to card draw. I want to use Sentinels here to talk about when a player draws a card. So Magic and many card games, you draw a card at the start of your turn. That kind of makes sense, matches intuition. Sentinels does the opposite. You draw your card at the end of your turn. And this is a cooperative game, about 4 players, superheroes versus a supervillain. And this does something interesting. So at the start of your turn, you have 5 cards in hand, and you've had an entire round to figure out what you're going to do on your turn. So that player is gone, Adam's gone, Cheyenne's gone. Everyone's taking a turn, and I figure out what I'm going to do. I make my turn, and then I draw my card. So I don't really... This is a trick, because you're not really limiting the decision tree in any way. End of turn is the same as start of turn in most cases. It's the same point in time. But it does give you more time to decide what you're going to do on your turn. So it's a really good trick. And this also reminds me of, you might have a thing in your game where you have a lot of things that happen at the start of a player's turn. And they might have decisions to make at the start of their turn as well. You should consider having them draw a card after they first make all those decisions, for a similar reason. Just why introduce more information into their decision space when they already have decisions to make? So let's talk about mulligan in card games. This is there's a lot of rich decisions to make in a mulligan. I think a lot of lessons can be taken from the mulligan. So in Hearthstone, they have a pretty soft mulligan rule. You have 4 cards at the start of your turn, and you just check which ones you want to replace. And then those get set aside, you draw back up to 4, and then those get shuffled back in. So a lot of games do this. A lot of games just have a full hand mulligan. Some games don't mulligan. But this, I think, is a good way to demonstrate a few ideas. So one thing with a mulligan is you consider your economy. I would love to play this behemoth right now. It's a 10-10. That sounds amazing. But I don't have 10 mana crystals at the start of the game. I have 1. So I'm probably going to throw away the behemoth and keep the rat. And so these types of cards are really good to give the player an option to play, because it really simplifies their mulligan decision. In a starting deck, I think I might give the player 1 faceless behemoth, just because that really enforces the idea of mulliganing to them. Another is this idea of duplicates. So this card, I didn't even know about this card until today, but it looks pretty cool. I gain a bunch of mana and I discard my hand. But if I have 2 of them, I discard the second copy. So maybe at the start of the game, I'll mulligan one of these duplicates, because I don't need both. And then lastly, there's the idea of strategy versus tactics. So if both these cards cost 2, I can play them both on turn 1 or 2. One of them is going to restore 6 of my health, which in Hearthstone I think doesn't have an upper limit. But maybe my strategy with this deck is about restoring health, which triggers my creatures that do something. There might be a lot of strategy involved there. And restoring health at the start of the game is not as valuable as maybe the tactical decision of lightning bolting, some creature that's annoying. So this is another thing that helps a player make a decision, is strategy and tactics. Going into a different realm is determinism. So we're talking about abstract strategy games here. So Go is probably the most decision-rich game I could think of, in that there's very few constraints where you can place a stone. I don't understand the game enough to even go into this in depth, but I think everyone has a basic idea what Go is about. So very few constraints, a lot of decisions. Chess is similar, is much more constrained than Go, but one of the things with chess is you have this whole idea of opening theory. And a lot of players really like opening theory. It's a great area of the game to study. It involves a lot of memorization. Here's just several chess openings that you could go into. And so there's a lot of space there but some players don't like the memorization as much. They really like the basic rules of chess, but they don't want to have to remember all these openings. And so there's a great version called Chess 960, which it's very simple. They just randomize the back row. Both players have the same back row, but it's randomized. There's 960 possible openings. And as a result, you can't really memorize anything. It doesn't benefit you. Opening theory has no real benefit here. You'd have to remember opening theory for 960 possible openings, and people have only written about one of these openings. So the chances you get that one are pretty small. So this is an option, and this leads into a game I really like called Hive, which is another abstract strategy game. The object of this game is to surround your opponent's queen bee, so that bee there would have to be surrounded by the white pieces and vice versa. And this game has really interesting and much more simplified opening theory. There's a few rules that put limitations on what you can do. So the game starts off with no pieces on the board, and the players add pieces next to each other and then next to their own pieces every other turn, basically. And the way the rules work is you cannot move one of your pieces until your bee is placed. You have to place your queen bee by turn 4. And you cannot move, I already said that, right? You cannot move pieces until bee. Yeah, and then the final thing is your new pieces have to be placed next to one of your, you can't be touching an opponent. And so what this does is it allows players to develop pretty strong heuristics. That's like soft decisions based on these constraints. And so there is some opening theory, but it's something you could explain to someone pretty quick. And it goes kind of like, there's few valid placements early in the game. There's limited information early in the game. I don't know exactly where my opponent's going to place their bee or their ant. And moving pieces is really strong in the game. You can move your ant to the other side of the board very fast, and that gives you another point to spawn pieces and gives you all sorts of tactical decisions to make. So you want to move pieces early if you can, and that sort of all comes down to it's generally good to place your bee before turn 4. You don't want to place it first, maybe not even second, so 3 might be a good turn. These are the kind of things that help players develop a heuristic when making a decision. And I've, even in my research, found other creative ways to trim down decisions. I think this guy was playing this game in the way that every turn he dove down to the bottom of the pool and had to place his piece before coming back up. And that was, I think, a really creative way to limit the decision tree, which goes right into time as a constraint. So this is a game called Galaxy Trucker. Some of you might be familiar with it. You build a spaceship out of tiles. It's really cool. Given no constraints on time, it would be super easy to build like the best spaceship. It would just be, pretty random. You kind of raced a spaceship, so it would just be random whose best spaceship wins. But the interesting thing they do on this is there's a bunch of tiles in the middle of the board, and there's no turns. You could just take a tile whenever you want. There's some rules in terms of how you exchange tiles and whatnot, but you just take a tile, and there's time limits. In the back there, you can kind of see the sand timer. And the rules in the game, as I remember, is like a player can just move the sand timer once it runs out whenever they want. And so the cool thing about this is you can't fully optimize if you're in the middle of a race, There's another form of chess. It's kickboxing chess, where you play kickboxing and then chess. And I think that probably limits your ability to optimize in chess when you've taken a few hits to the head. I don't know how that's related to this. But anyway, so something I think is really cool about this is sometimes a bad choice is really the best choice. Like you might put a thing down in your spaceship that is not even close to the right piece, but you don't want to spend the time finding the right piece or wait for that player to put that piece back. It's better for you to be the first person to finish your spaceship because you get a bonus. So this game uses time in a really fascinating way. I wanted to quickly mention Codenames because it also uses time. This is probably everyone's here familiar, but just in case someone is not, it's a word guessing game. You try and guess words on a table. One person's the clue master, giving you these clues to help you find your words on the table. Anyway, playing as the code master is one of the more difficult things you could do in a board game. It's just incredibly intense and taxing on your brain. It's very difficult to find a good clue. And something they did in this game is they just included the sand timer, and the rules basically say any player at any time can flip over the sand timer, and that's it. It doesn't have any connection to the mechanics. It's totally artificial, in other words, but it still works. It still absolutely works. And sometimes when I'm playing, I'll even flip it over on myself. And something about the rush to finish in time, even though it doesn't mean anything, forces me to come up with the right decision. So Codenames, I think that was really smart of them to do. It probably added not an insignificant cost to their production, but totally worth it. And last, I wanted to go into probability. So benefits of probability, there's no right answer. There's like, I can figure out the probability, but it might come down to a 50-50, and I just have to make a call. And often that call is based on what I think my opponent is doing. So computability is pretty easy for someone to evaluate, and there's a lot of soft decision making. And I wanted to bring this up because I get to talk about Netrunner, which is my favorite card game. It is a game of probability. It's a card game of cyber struggles in a dystopian future, so that probably explains it. But at a high level, what you're doing is one player has these cards in their deck called the agendas. These are the corporation has these secrets that they're trying to push through the pipeline, and this one, I guess, is they're trying to put advertising on the moon, so that's the idea. And the runner, or the hacker, is trying to find these agendas and expose them before those agendas are scored by the corporation. So this is what it kind of looks like when you play, and is you have a hand of cards here, 5 cards, and if I'm the runner, I'm trying to find which of those is the agenda. In some cases, it's 1 in 5. In some cases, it's 4 in 5. And sometimes it's 0 of 5. I just don't know. There's definitely agendas somewhere. So it really changes the decision, the context of the decision space from can I do a thing to should I do that thing. There's plenty of times I'm playing this game where I know if I do this thing, I can score points. But it's not always the right thing to do. And often that's related to the probability. So this game has a lot of hidden information as well. And that's where, going back to this slide, we see if I know one of these is an agenda and it costs me 3 resources, should I spend 3 resources for a 1 in 5? Maybe, maybe not. It just depends on a lot of other factors. So to summarize, these are sort of the tools you can use while pruning. You can limit hand size. There's card draw restrictions. You can still have abstract strategy, but without a huge amount of memorization required. Time is an interesting tool to use, not for every game, but it's going to be really good for some. And probability and hidden information are extremely valuable tools that I think more games could leverage. So say no to analysis paralysis unless you're into that sort of thing. And that's the talk.